Welcome to Section 8, Cyber Resilience Improvement, Control Objectives and Interactions with ITSM. The amount of content in this section is similar to what we noted in service design earlier and also in service transition. Of course, it's a different topic now, and there'll be 8 questions in the exam from this subject. The syllabus for the exam is to identify what cyber resilience continual improvement is intended to achieve, recognize maturity models and their purpose, describe the controls from cyber resilience improvement, namely, there are 6 of them. Audit and review is the first one, followed by control assessment. Then we have KPI, KRI, and benchmarking, which is key performance indicators, key risk indicators, and benchmarking. Then we have business continuity improvements, process improvements, remediation, and improvement planning. We will also deal with the 7-step improvement process, which can be used to plan cyber resilience improvements. And also there's the ITIL CSI approach, continual service improvement approach to plan cyber resilience improvements. The last topic, the approach, is more like a model of improvement or a methodology for improvement. Whereas the 7-step process is a data-based process. To begin with, what is cyber resilience continual improvement? It is a set of attitudes, behaviors, and culture that helps to ensure cyber resilience continues to provide the protection needed in a constantly changing environment. So it's a culture where mistakes are seen as opportunities to learn, and honest feedback is valued and essential. It applies to all the stages of the service life cycle, meaning service strategy, service design, service transition, service improvement, and even continual improvement. So it applies as it indicates here, including how continual improvement itself is managed. The objective of this in cyber resilience is to ensure that the controls or protections that were designed and implemented in the design and planning phase continue to remain effective over time and provide the desired protection, and that they are continually improved to protect against new threats. Now, this picture here shows we have strategy, design, transition, and operation, and it indicates the output of each phase become input to the other. So strategy outputs become input to design. Similarly, design outputs become input to transition, and transition outputs become input to operation. But if you notice, there is feedback coming from design to strategy, transition to design, transition to strategy as well, operation to transition, operation to design, and operation to strategy. And also at the bottom, we see continual improvement is embedded into every stage of the life cycle, meaning the remaining 4 stages. So some examples of feedback could be when we look at feedback from design to strategy, the feedback could be that we need more funding to meet the design demands. And feedback from transition to design could be that agile way of working would be better due to too many changes happening. Then operations to transition example could be that feedback could be that there is the production environment that has been created is quite weak. And think of feedback to much earlier phases also than to just the previous phase. So while I've gave you examples just to the previous phase feedback, but there could be feedback to even the much earlier phase. So meaning operation can give feedback to strategy as well, as an example. So the control should remain appropriate and effective due to 3 reasons. Firstly, a continual changing threat environment, then continually changing business environment, and continually changing technology environment. So from a threat environment, an organization must constantly monitor whether it could be vulnerable to attacks that have affected other organizations. From a business environment change perspective, previous risk analysis may longer be appropriate for business needs due to new customer expectations, new business opportunities, new laws and regulations, and new competitive pressures requiring higher levels of confidentiality, integrity, and availability. Continually changing technology environment. This is where previous controls may no longer be effective due to new infrastructure, applications, and services that require updated, expanded, or completely redesigned controls to achieve the same effect. We'll take a look at an example. So we have the examples on this slide. Firstly, we have the threat environment example. In 2010, it was discovered that industrial control systems based on SCADA supervisory acquisition and data control, these were vulnerable to attacks from a cyber threat called Stuxnet, even if they were completely isolated from the internet. So this required every organization with a SCADA system to review and update their process for managing updates. The updates used to be done using a USB drive or a disk, and therefore it was possible to bring a different USB stick or a disk and insert that and do the update, which was a malicious update. Changing technology example. For example, a user authentication scheme based on locally managed users' names and passwords, which was ideal for a single server environment, may not provide the appropriate level of protection in a new cloud environment, where software is supplied as a service by a third party. Business environment changes example. Many businesses become competitive by converting physical activities into virtual activities on the internet. Basically, online stores, so moving a store from bricks and mortar to a website. So these changes require significant investment in cyber resilience controls because virtual activities are critically dependent on the CIA of information. So as an example, an organization may have sufficient controls to protect its website when it was only used for sharing information with customers. But if it adds internet shopping capability to this website, then it may need to invest in significant hardening of the server due to the increased exposure, hardening meaning specific configuration. Alternatively, it could outsource the internet shopping capability to a third party, but this would require investment in increased capability to manage cyber resilience risk from suppliers also. Here we see the controls for cyber resilience continual improvement, just like we had controls in the previous stages, such as strategy, design, transition, and operation. We have here 6 controls. The first one is cyber resilience audit and review. Then we have control assessment. Then KPIs, key risk indicators, and benchmarking. Business continuity improvements, process improvements, remediation, and improvement planning. Let's pick one at a time. We begin with the cyber resilience audit and review. This is to help an organization to identify where it is in continual improvement and to plan improvement of cyber resilience controls. You might recollect that we had the cyber resilience audit and compliance in strategy controls, but here we have resilience and audit review. So there's a slight difference there. Next, this also helps tackle new vulnerabilities known as zero-day vulnerabilities. For example, the Heartbleed OpenSSL flaw exposed millions of websites and products to threats. So the Heartbleed vulnerability allowed a malicious user to trick a web server to send sensitive information like usernames and passwords. That was bad. Initially, it was discovered in 2013 by Google, and shortly it was discovered also by Codenomicon. It's a Finnish cybersecurity firm. And the OpenSSL code got corrected within a year or so after this happened. Then it also helps an organization to revalidate existing cyber resilience controls, test their assumptions, and plug gaps and improve controls. The audit may be internal or external, but it should be independent and objective. For example, security standards such as ISO, IEC 27001 require internal and external audits for certification of the Information Security Management System or the ISMS. An organization operating in a compliance-driven industry such as finance will already require auditing and review of its controls. There are industry compliance standards such as the PCI DSS and SAE 16, which is the Statement on Standards for Attestation Engagements, SSAE number 16, require regular review and compliance audits. Then the SSAE 16, it was created by the American Institute of Certified Public Accountants. Further, in this audit and review, cyber resilience applies to entire organization, whereas compliance with industry standards has limited scope. So, for example, PCI DSS applies only to security of cardholder environment. Next important point, it is important to continually review and assess effectiveness of existing controls with a view to improving them replacing them if no longer needed, or removing them completely if they cause significant business impact and the threat no longer exists. Controls can be technical or non-technical. Non-technical are also known as managerial or uh, procedural. We see an example in the box at the right, the technical control example, a traditional firewall that was effective. It was installed several years ago, but no longer an optimal control. And this could be due to a change in business operation or technical environment, such as a launch of a new product or deployment of a new e-commerce application using web services. The traditional firewall may now need to be replaced with a web application firewall that is able to handle more sophisticated application-borne attacks. So the WAF, the web application firewall, actually protects the web application by filtering, monitoring, and blocking malicious traffic that might penetrate the web application. And it can be network device based, part of the application software itself, or now it is cloud based also in the cloud environment. The non-technical control example, review firewall logs more often and retrain people to recognize and respond to new types of attacks.